Hi there, welcome to Leap, where you learn once and remember forever. This video is the part 2 of Graphing of Quadratic Polynomials. In the first video, we discussed in detail about the features of a parabola. Moving forward, the next step is to understand the transformations of a parabola. So in this video, we are going to discuss about the different transformations that involves a combination of dilation, reflection, and translation. For those who are watching Leap videos for the first time, I am Deepika, a mathematics teacher based in Melbourne who tries to make maths as easy as possible. Let's get into the video. We know that the standard form of a quadratic polynomial is ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Now what we are going to do is, we are going to change the value of a, which is the coefficient of x squared, and see what happens to the parabola. Now we'll start with the basic quadratic polynomial, which is y equals x squared. So this is how the graph of y equals x squared looks like. Now I'm going to include a slider by adding an a as a coefficient of x squared. Now let's see what happens when I keep changing the value of a. So when I increase the value of a, this is how my parabola looks like. And when I decrease, this is how it looks like. So you can see that as the value of a increases, the parabola becomes more narrower. And when I decrease the value of a, it's becoming more broader. This movement of parabola is called as dilation. Let's make some notes. So dilation means whether the parabola is becoming broader or narrower. So that depends on the value of a, which is the coefficient of x squared. So if the value of a is greater than 1, the graph becomes narrower. And if the value of a is between 0 and 1, the graph becomes broader, which is more wider. Now let's see what happens to the parabola if the value of a becomes negative. So let's try to give it a negative value, let's say negative 1. So you can see that the parabola is now open downwards, which is the opposite of the positive value. So whenever we gave a positive value, the parabola was open upwards. But when we move to the negative side, we can see that the parabola is open downwards. Now, as we keep increasing the number, we see that it becomes more steeper, which is narrower. And when I decrease the numerical value, it becomes more wider, which is more broader. So this movement of parabola from concave up to concave down or concave down to concave up is called as reflection. Now let's take some notes. So reflection basically gives you an idea of whether the parabola is open upwards or downwards. So if the value of a is a positive value, then the parabola is open upwards. If the value of a is negative, then the parabola is open downwards. Let's see what happens to the parabola if we try to add or subtract a number to x squared. So I'm going to add that as a new equation so we know from the actual graph how the real change happens. So y equals x squared. Let's say I'm going to add 1 there. So you can see that the graph has moved up by 1 unit. Let's say I change it to plus 2. You can see the graph has moved up by 2 units. If I change that to negative 2, I can see the graph has moved down by 2 units. So it is all in relation to the actual graph, which is y equals x squared. So from here, it has moved 2 units down. Now I'm going to add a slider here so you can see what happens every time the c changes. So as the c keeps changing, you can see that the graph moves up and down by as many units as you have mentioned. If it is a positive value, you can see that the graph is moving up. And if it is a negative value, you can see the graph is moving down. This motion is called as translation. Now this translation can also happen from left or right. So the graph can also move towards the left side of the x-axis and to the right side of the x-axis. For that, what I'm going to do here is I'm going to change the x squared term as x plus 1 the whole square. Okay, so you can now see the actual graph is the red one. So you can see the graph is now moved 1 unit towards the left. So when you added 1 here, you can see it has moved 1 to the negative direction. So this is basically the opposite, isn't it? Because usually we will think if we add 1, it has to move to the positive direction. But then when we add 1 here, it is actually moving in the reverse direction, which is the negative direction. So let's see what happens if we do negative 1. So I'm going to change it to negative 1. So you can see that it is moving to the positive direction, right? So I'll keep changing the value. Let's say minus 2. So you can see from the main graph, which is 0, it has moved 2 units to the right. So minus means right side and plus sign means left side. So I can give you a slider here for you to better understand how the movement takes place. I'm going to give the positive values and you can see it is changing in the negative direction. So as I keep changing it to the negative value, you can see it is moving towards the right side. So this is called as translation along the x-axis. Now let's take some notes. Translation means the movement of the parabola either up or down or left or right. So the up and down movement is basically decided by the k value. So if you're going to add a value to x squared, it is going to move the parabola up by that many units. If you're going to take away a value, which is if you're going to add a negative value to x squared, the parabola is going to move downwards that many units. The same thing applies for left or right. It's just that as you add a positive value to h, you get the parabola moving to the left. If you give a negative value to the h, you get the parabola moving towards the right side. So the only thing here is the movement is the opposite way compared to the up and down movement. So up and down is usually positive for up, negative for down. But here positive is towards the left side, negative will be towards the right side. Let's try to do some sketching using transformations. The first question is to sketch a graph of y equals x squared minus 3. So this minus 3 is a constant. Now the constant decides whether the graph moves up or down. This is negative 3. That means the graph moves 3 units down. So 1, 2, 3. This is the graph of x squared minus 3. Let's try another question. X minus 2 the whole square. So you can see that this minus 2 is taken away from the x, which is in the x squared term. So that means this is a left or right movement. Now we know that the left or right is always the opposite direction. So when you have negative number here, that means it moves to the positive direction, which is towards the right. So minus 2 means the graph moves to the right by 2 units. So this is the answer. Let's try another one. Y equals negative of x plus 1 the whole square. When it says negative, we know that the graph is upside down. And now we are looking at the value here. It says plus 1. So and then again the plus 1 is added to the x of the x squared term. That means it is a left or right movement. We know the left or right movement is always the opposite direction. So if it is plus 1, we move to the negative direction. So the negative direction would be from the x squared graph, it is going to move negative direction by 1 unit. So that's our final graph. Let's try one more. Y equals x minus 1 whole squared plus 2. So this means plus 2 is basically moving up or down. So plus 2 is moving up. So let's try moving up. And then x minus 1. That means This -1 is your left or right movement. It is in the opposite direction, so minus means you need to move to the right side by 1 unit. So it moves to the right side by 1 unit. So this is the graph of x minus 1 the whole squared plus 2. Let's try one more. So y equals x plus 1 whole squared minus 2. All right, the constant here is -2, which means the graph moves 2 units down, and then it says x plus 1 the whole squared, so we move left side by 1 unit. So from here you can move to the left by 1 unit. So this is the graph of x plus 1 the whole squared minus 2. All right, let's try last question. The question is sketching -2 times x plus 1 the whole squared minus 3. So this question has all the 3 factors. It has dilation factor, it has translation left or right, translation up or down. All right, and also the sign shows that it is upside down. So there are 4 things to be done. The first thing is it is negative. So I'm going to flip this and put it in the upside down direction. So it's now open downwards. All right. So the first thing is the translation up or down. So it's -3. So it's translation down. So move down. Next is +1. That means left or right. So this is opposite direction. So plus means negative. So we move negative by 1. All right. The last thing is the dilation factor. It says dilation 2. So 2 is more than 1. That means the graph is going to be narrower. So this is how the graph will look like compared to y equals x squared. This is how you do the graphing using transformations. Now, the next question is for you to try. So maybe give this a shot and leave your answers in the comment section. If you're not able to add an image there, maybe just mention whether you got it right or not. You can check your answers using Desmos or GeoGebra. I hope you were able to understand what is dilation, reflection, and translation, and also how to sketch graphs using these transformations. If you have any questions or doubts, please feel free to leave them in the comment section and I'll get back to you shortly. If you liked this video, please give a thumbs up and please follow Leap to learn more and make maths as easy as possible. Thank you.